Hey boys and girls, today we're doing video note 7, part 1, which is solving one-step equations. Now the reason why we call these one-step equations is because there's only one operation to be performed to solve it. Okay, I'm going to tell you a little bit about the concept of solving equations, which is sometimes also called balancing equations. So let's pretend that these four pins are sitting on the scale. So it's balanced right now because we have two on each side. Okay, but what happens if I remove a pin from the left side of my scale? Then we know that our balance is off. So the way to get it to be balanced again is I have to remove a pin from the right side as well. And it would be the same with adding. If I were to add a pin to the left side, I've got to add the same exact amount to the right side. So this is the same concept that we use when solving equations because we're trying to keep our equation balanced. So whatever we do to one side, we do the same thing to the opposite side. Okay, let's get started. Now, I am going to be using these colored pens when doing my notes because I do like to color code. That's a very good thing for you to do whenever you're doing math notes. It just makes it easier for you to see all of your different steps. And although I am writing in pen, you're going to be doing some examples on your own. So please use your pencil when you do that, just in case you make mistakes. And the examples that I have you do on your own, we will check in class. Okay, let's get started. Okay, the way we're going to solve equations are we use inverse or opposite operations. So to solve an equation, use inverse or opposite operations. And what I mean by inverse operations, inverses are opposites. So therefore, addition and subtraction are inverse operations. And then we would have multiplication and division. So addition and subtraction are inverse operations. Then multiplication and division are inverse operations. Now keep in mind that we do have a main goal when solving equations, and that is to isolate the variable. And you should notice a couple more vocabulary terms, which is isolate. So you should remember that isolate means we're trying to get it by itself. And you should know your variable is your letter. Okay, let's get started. Example 1, we have an addition equation. And we can tell that it's an addition equation because we see that it says x plus 4. So 4 is being added to x, which that's what makes an addition. So to solve this equation, remember, I want to use its inverse. So I need to use the inverse of addition. So since the inverse of addition is subtraction, then that means I'm going to subtract 4 from both sides. So I'm going to subtract 4 from the left side, which is going to get those 4s to cancel. And I also have to subtract 4 from the right side because remember, whatever we do to one side, we must do the same thing to the opposite side. So now I'm left with x isolated, and it equals -6. You still need to remember your integer rules. A negative plus a negative, or -2 minus 4 is -6. Okay, now we're going to check. And when we check, All we're going to do is substitute our solution and solve. So we're going to substitute -6 in the parentheses and solve. So -6 plus 4 is -2. And since -2 equals -2, it checks. Okay, you're going to pause the video and you're going to do part B. We will check it in class to see how you did. And example 2. This time we have a subtraction equation because it's C minus 6, so that means that 6 is being subtracted from C. So in order to solve our subtraction equation, remember we've got to use the inverse of subtraction. Which is addition. So in this case, since 6 is being subtracted from both sides, to solve it, I'm going to add 6 to both sides. So what it looks like is I'm going to add 6 to the right side. I'm going to add 6 to the left side. When I solve, 13 plus 6 is 19. Bring down the equal sign. 6's will cancel, so I'm left with C, isolated. Now we typically want our variable to be on the left side, so now all you need to do is switch sides. So we're going to write C equals 19. And check. So since the parentheses represents our variable, plug in your solution and solve. So we have 13 equals 19 minus 6, which is 13. So since 13 equals 13, it checks. Now you're going to pause the video and you're going to do part B over here. And we will check that in class. And don't forget, you're supposed to be using your pencil. Okay, in example 3, which is a multiplication equation. I have 2p equals -18. So I have 2p. Oh, wow, I do have 2p. Hold on a second. Never mind. Just kidding. All right, let's keep going. Okay, since we are doing a multiplication equation, remember we need to use its inverse, which happens to be division. So we're going to use the inverse of multiplication, which means I'm going to divide both sides by 2, since 2 is the number that's attached to the variable. So first I'm going to rewrite my equation as it is. And then I'm going to divide both sides by 2. So my 2's on the left side are going to cancel, which leaves me with p equals -18 divided by 2 is -9. Now let's check. Substitute -9 and solve. 2 times -9 is -18. Since -18 equals -18, then it checks. Alright, you know the routine. Pause the video and do part B. We will check it in class. Now I'm going to be nice and give you a little hint. That's a -4c. So remember, you have to divide both sides by whatever is in front of the variable because we're trying to isolate the variable. Example 4. This time I will be nice and I will do the harder one for you. So I'm going to go ahead and do B. And I'll let you have A. So this is pretty much what you should have done for the one right above. Okay, we have negative b divided by 5 equals 4. So since these are our division equations, then we're going to use the inverse of division, which is multiplication, to solve. So what I want to do, because I never want a negative variable, is I'm just going to take my negative sign and I'm going to put it on the 5. So I'm just going to rewrite this like this. And remember, to solve, we're going to use the inverse of division. So since the inverse of division is multiplication, and I need to isolate this variable, so I need to remove the negative 5. So therefore, I'm going to multiply both sides by negative 5. So I'll put both of these in parentheses and multiply both sides by negative 5. So just write negative 5 on both sides, because you should know a number outside of the parentheses means we're multiplying. So these negative 5s are going to cancel, leaving me with b equals 4 times negative 5, which is negative 20. That wasn't so hard, was it? Let's check. Let's substitute our solution, which is negative 20, and solve. Since you should remember that a negative divided by a negative is a positive, then negative 20 divided by negative 5 is 4. And since 4 equals 4, it checks. Okay, you're going to pause the video and you do A. Okay. Sorry, I did forget to write down what we did here. So what we did was multiply both sides by negative 5, not just 5. Okay, last couple examples, we basically have already done each type, because we've done a multiplication and we've done a division. But I just wanted to show you that your answer may not always come out as a whole number or a regular integer. So in example 5, we have negative 5a equals negative 36. So therefore, I need to isolate my variable, which means I'm going to divide since it's a multiplication equation. So I'm going to divide by the number in front of the variable, which is negative 5. The negative 5s are going to cancel. And I'm going to end up with a equals negative 36 divided by negative 5. Well, you already know that that's going to be a positive answer. And you should know that 5 doesn't go into 36 evenly. So you're going to have to come over to the side and divide it out. Since 5 goes into 36 7 times, with 1 left over, then we know that we're going to end up with a decimal answer, or either a mixed number. So I'm going to add a decimal in the 0 and bring my 0 down. Don't forget to put your decimal point in your quotient. And 5 goes into 10 twice. So therefore, a equals 7 and 2/10. Okay, let's check it. Although I didn't put it on there for you. So remember, when we check, we write negative 5, put parentheses where our variable is, and it equals negative 36. Now substitute in your solution and solve it. Okay, if you need to show your work again, just move over to the side and multiply out 7 2/10 times 5. Because you should know, since we're multiplying a negative times a positive, it's going to end up being a negative when we're done. And since I need one decimal place, and that gives me 36. So I end up with negative 36 equals negative 36. And that checks. Could be it. Okay, in example 6, which is our final example, I started to make y'all do this one. Yeah, go on do this one yourselves. We'll check it in class. Alright, I'll be nice. Let's go. This is a division equation, so therefore we're going to use multiplication to solve. Since x is being divided by negative 1 4/10, that means I've got to multiply by negative 1 4/10. So therefore, I think I should have made y'all solve this one yourselves for real. Go ahead and rewrite it. And put both sides in parentheses. And since we're multiplying both sides by negative 1 4/10, we're going to write it on both sides. Now, those cancel, leaving me with x equals 1 4/10 times 5. And we need one decimal place. Now, positive times a negative is a negative. So this is basically negative 7. Because we can drop that 0 right back there. Now, you can check to make sure that this is correct. And we'll check it in class. And that's the end of video notes 1, solving one-step equations. Sorry, video note 7, part 1, solving one-step equations. Goodbye, boys and girls.